Hi folks, let's solve another problem. So this is the linear problem. We see it is the maximization function, profit maximization function, and the constraints number 1, 2, 3, 4, 3. So we have three constraints, 1, 2, 3. We have three constraints. Okay. Now what we want to do, we want to change it into the dual form. We want to change it into the dual form. Dual form. So what is dual form? Dual form is the form which is the double form or the duplicate form of this. It must give you the same optimum solution if you solve this linear programming model or the dual programming model which I'm about to make. The answer would be same. Okay, let's make it the dual form. First of all, you need to see that whether this into the canonical form or not, whether it is in the canonical form or not. So what is canonical form? Canonical form says that whenever there is a maximize objective function, the inequalities must be less than. So luckily they all are less than, so there is no need to intervene. Otherwise we need to multiply -1 on both sides, so the inequalities are inverted. Anyway, let's move ahead. So first of all, canonical form, then we move ahead, and in that you see what we do. We invert from the maximization to the minimization. We know that either we maximize our profit through the best utilization of resources, or we minimize the cost to maximize the profit. So it's in our hand. So both are same basically. Both are same. So let's move ahead. So in the minimization, you see Z, instead of Z we will be using the W, because we are making the double form. It must be different from this form, and the symbol will be y1, y2 and y3 instead of x1, x2, x3. So the coefficients I have not written. Why? Because the coefficients will not be the same. Instead, the coefficients would be the right hand side of our constraints, the linear programming model constraints. That is 10 plus 10 plus 2 plus 6. Okay. So now we are done with the objective function of the dual form. Let's move ahead for the constraints. For the constraint, what we have to do, we have to make the matrix first of the coefficients, of all the coefficients we have. So the matrix would be 1 plus 1, 1. Second constraint 2, minus 1, minus 1. That is 2, minus 2, minus 3. So these all are the coefficients of the constraints. We need to transpose them. So when we transpose it, what will be the value? What is transposition? Transposition is converting row into column or column into row. So we will be going towards the row into column. So row is converted into column, row is converted. These are the rows. These are the rows, and these are the columns. So we are converting rows into column. Okay. So you see row 1, row 2, row 3. Row 1 is converted into column 1, 1, 1, 1. Okay. 2 minus 1 minus 1. So 2 minus 1 minus 1. Row 3, 2 minus 2 minus 3. 2 minus 2 or minus 3. This is transposed. So now we have got the coefficients, and we already know the symbols y1, y2, and y3 we have. And we also know that in minimization we use the inequality is greater than equals to. Inequality is like that. So inequality is there, symbols are there. Now we have to put the values 1, 2, plus 2, plus, be careful about the signs, plus 2. And instead of the 10, right hand side of the constraint 1, we will write the objective function, linear objective function coefficient value, that is plus 1. Next is y1. We don't write 1, so I'm just writing minus. So you see, be careful, minus y2 minus 2 y3. Inequality will be same and the coefficient would be minus 1. Now next is 1 y1 minus y2 minus y3. 1 minus 1 minus 3 then equals 2, and it is 3 plus 3. Plus 3 is the x3 coefficient. This is done. We need to write y1 comma y2 comma y3 greater than equals to 0. So we are done with the duality problem. So when we will go for the solving it, so we never keep it the -1, so we will have to convert it. So anyway, if we will going to solve it, we will multiply minus on both sides, so it will be converted. Then we will be solving it. Thank you very much.